So yeah, again, if you want to do some art stuff, check out, listen to Transformer. It's pretty cool. It's awesome. And this is especially if you're like wanting to do something much more artistically inclined whenever you decide to do a final project. Combining, I don't think computers personally will be able to really replace certain types of art, but what we've seen in chess is that like humans, AI beats chess. Sorry, AI beats human in chess, but these days, but human plus AI beats AI. So at least anecdotally from what I hear. So using these things to like this, these are some standalone applications. You can drop in some MIDI files. And again, those are just basically, you can drop in some music and say, I need you to help me get through my writer's block, generate more music. Those kind of things, you can see that being super useful for like applications when it comes to writing a book. Everybody talks about writer's block when they're writing a book. It's a trope. Well, throw what you have at it and see what the next couple of what different possibilities for the sentences are. I mean, NaNoWriMo has the general idea of if you can't write, if you don't know what to write next, have ninjas attack. So, but that doesn't always work for every novel, sadly. So anyway, let's go ahead and talk about what we want to do today. What we want to do today is actually particularly interesting. You'll want to go to runestone.academy. And you'll want to click on our course, Spring 2021. And today we're going to work on problem 3. Do you think the result of the creative process is as meaningful if that happens? I actually do. I think that so long as it's entertaining and evokes emotions in the audience, then it is just as meaningful. I think that basically it's just a matter of being able to save us time, and which is basically the one thing we can buy GameStop stock all we want. Well, we could until today, but we cannot buy extra time. We cannot buy extra time. So anything that saves us time, even if it does make the output slightly more artificial, that is something to consider. I think there is something to be said, like, for something that I think there will always be some a place for like things that are completely artisanal, completely human made. But I think that something that having the computer help is just another tool. All right. So now for those of you who don't necessarily, let me go ahead and I'm going to open this in because I have some notes here on another page. Okay, so Instructor Notes. So one of the really interesting, so there used to be like these quote unquote meaningless questions that software interview companies like to ask prospective interviewees, like Brian, ask me about book suggestions at the end of the class. I'll be more than happy to go through some book suggestions. So there were these meaningless questions like why are manhole covers round and the like. But one was like, but there was one that was, and those kind of things are like less useless. There are questions that are less useless, like how many houses would it take to, how many houses would you have to stack beside each other and on top of each other to equal the height of the Empire State Building, right? And the question is like, how do you even begin to answer questions about that? There was another question. How many gallons of water or how many liters of water flow out of the Mississippi Delta every day? How do you even begin to answer questions about that? And part of this is not really a skill that gets ever taught in computer science, but that's not going to stop me from trying to teach it now, which is how do we make good estimations? Now, for those of you who are unaware, there's this webcomic that's really great called Xkcd. Okay. Xkcd is just got a bunch of nerdy math and science science comics, but he a number of years ago, he started running a blog called What If, which he was able to publish into a book, which basically people asked him very absurd questions, but he would give serious scientific, answers to. Let's see. Will a toaster still work in a freezer? Right. And then he'd go through and analyze the science about it. What if the entire continental US was on a decreasing slope from west to east? How steep would the slope have to be to maintain the momentum to need to ride a bicycle the entire distance without pedaling? So questions like that, they're answerable, but how do you begin to answer them? Now, one of the questions that he got, which I think is really relevant to these kinds of questions, which is that if all digital data was stored on punch cards, how big would the Google data warehouse need to be? Right? So first off, what in the world is a punch card? Anyone, any takers on that one?
It kind of seems like one of those
Scantrons? It looked like a Scantron was what you're going to say?
Like a business card with a hole puncher thing, and it's like when you get enough something, you get a coupon.
Free pizza coupon. Great. Danielle says first way to program. Pretty much. It was the first really efficient way to store programs, which was that you would put your programs on punch cards, and you would utilize them in the computer, and basically they would represent different commands or different things or different pieces of text. And so you'd punch the holes in the card, you'd take over your program, and you'd feed them into the card reader, and it would read them. God help you if you dropped your program and you didn't have the pages and you didn't have the cards numbered, because you might as well just start over at that point. Anyway, it was an old way of doing it. So first off, now Google, we're operating under the assumption that Google would be the biggest. We don't know necessarily how big they are and how much data they have, but it probably has more than anybody on Earth, except for possibly these possible peoples, such as the NSA, the CIA, the NRO. Anybody know off the top of their head what the NRO is? It's one of the top 5 intelligence agencies in the US, right? You've got the CIA, FBI, NSA. And National Reconnaissance
National Reconnaissance.
Okay. Office. Above all others. And in case you're wondering what they do, right? FBI is all about domestic threats. CIA is all about foreign stuff. So what in the world, if it's not domestic or foreign, what the heck is it? Oh, NSA is signals. Well, they do satellite data, which you could imagine if you're doing satellite data, that's a lot of data. So, Tencent possibly has tons of data. Honorable mentions, right, are Facebook, Amazon, and Microsoft, who are big, but they are not as big as anyone else. Again, this is back from, let's see, actually, I have no idea when he published this, but it is quite a bit. Let's go ahead and follow money. So how much Google data does Google have, right? Well, they do cache things, and we're asking if we store all of Google's data in one place. So he basically walks through following the money and says, hey, they've got $12 billion on building stuff. Here's their data centers, and they have a number of other data centers. And then the other thing is, to figure out how many servers are in each of them, we can look at their electricity consumption, but we can't just go over to the data center and read the meter. Actually, wait, can we? Somebody should try that. So what you can do is that they look, like in 2010, they said, oh, we use 258 megawatts of power. So how many computers can you run with that? So he basically eyeballs it as 215 watts a server. Hold on a second. Is he counting up above 100 now?
Yep.
Oh, that's impressive. Good job, Lisa. All right. So it says 215 watts a server. And then he estimates that if each server has 4 terabytes, they say they can come up with estimate that Google has about 10 exabytes of data, which is a refresher for those of you who don't use Exa too often. That's kilo, mega, giga, tera, which is what's in computers these days. And then 1,000 tera would be peta, and 1,000 peta would be exa.
I put all the lids back on them.
So an exabyte would be about 1,000,000 terabytes.
So that they don't dry out and stop writing.
So, and then basically he says, okay, so let's assume Google has a storage capacity of 15 exabytes or this many bytes. That's a lot of zeros, too many for mere mortals like us to comprehend. Punch card can hold 80 characters. So, and a box of cards is 2,000 cards. And so he estimates that this would be that 15 exabytes of punch cards would be deep enough to cover New England to a depth of about 4.5 kilometers. But picture for scale. So somebody else points out as a last amusing thing, though, the best trick for finding secret Google facilities might be one revealed by an ex-Googler. The easiest way to find manned Google data centers is to ask taxi drivers and pizza delivery people. For pretty obvious reasons. But anyway, that is just like the kinds of questions that we can answer with like having some very powerful programming. So let's look at another example of this, right? Enter a number of years and I'll tell you how many minutes this is. So this is a very common program and something we'll see, something along the lines of what we're going to do when we do for one of our programs for the next assignment. So here, give me the number of years and I'll tell you how many minutes that is. Okay. So remember what this code does is that when we run it, comes here in the web browser, it's going to come up with a text box. But if you're running it locally on your own computer, it will just be on the console. So give me a number of years. Let's go with 100 years. And it says 100 years is, let's go ahead and see 1, 2, 3, 4, 5, 6. 100 years is 52 million minutes. So let's go through this line by line. You take in an input, you store it in years. Then you have this line over here, int years. Okay. Now, if you notice in lines 3, 4, and 5, you're doing a bunch of numerical operations, specifically multiplication, right? You don't really want to multiply by multiply a string and an integer together in this context. A string is text, right? Here, when we take an input, even if we enter a number, this is text, right? That's text. It may be a number, but it is text because I'm entering it as text. So we tell Google, hey, not Google, but we tell Python, hey, this text. I want you to turn it into a number so I can use it, and then store it in the variable called years, which just happens to be the place where you got it from. So all this line does is change it from a string, which is what we call text in programming languages, to a integer. Sounds really exciting downstairs. All right. And then what does it do? It says, hey, well, years times 365, multiplying years by 365 gives us the days. It is located going to here, going to Runestone Academy, logging in, and clicking on Project 3. So days times 24, you take the number of days, multiply by that 24, and you'll have how many hours there were, and take the number of hours there are, multiply by 60, and you'll have the number of minutes. So again, there we go. So now let's go ahead and give this a try. So let's go ahead. Can you change the, so let's go ahead and try this a bit. Can you change this so that this above problem will give me the number of seconds rather than the number of minutes? And then can you go and then maybe if that seems a bit easy, why don't you try going the other direction? Given the number of seconds, tell me how many years there are, right? And then let's see, enhance part 2 so you can print the number of years, months, days, and minutes. Okay, that gets a bit harder, but let's go ahead and take 5 minutes to play around with that and choose one that you feel is appropriate to your difficulty level. If you're just starting out, try number 1. If you're a bit more comfortable, even if you are just starting out, try number 2. Right? And if you think you're a ninja, try part number 3. I'm going to go ahead and give you 5 minutes to work on it because that, and then that also gives me a chance to see what's going on down, what kind of craziness is going on downstairs for 1 minute. So I will be right back. I'm back. Toddler's gonna toddler. I'm gonna start out by working on part 2 myself.
Professor,
Yes.
you said for hours, you said seconds.
Oh, yeah, I did. I mean, I've got to go and debug my code still. It's very easy to do that. It's very easy to make mistakes like this. Please enter the number of seconds. So I'm going to put in this many seconds. So 1, 2, 3. So it says that 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 seconds. So 100 million seconds, about 3 years or something. Right. So I did part 2. If you wanted to do part 1 is fairly straightforward, which is to just modify this to say seconds is equal to minutes times 60. How many? Because there are 60 seconds in a minute. Honestly, if I were to say where the math, being good at math comes into play, for computer science, really it comes down to, were you good at word problems? If you were, then you're going to be able to understand the computer science problems. So enter the number of years, and I'll tell you how many minutes of it is. So 3 years. And now we have to go ahead and fix this. Seconds. Seconds. Save. All right. So were people able to get close with, able to do this one? Or did they get stuck somewhere?
I was able to do this one. It's just the second one that seems like a little bit of a tricky one because it's like you got to flip it.
You've got to flip it, right? Which means you got to do division instead. So let me go through the answer for the second one. Okay. So here you're just taking the number of seconds. So then you got to ask yourself, how many seconds are in a minute? So I'm going to divide by 60. How many minutes are in an hour? 60 again, because for some reason we decided to make our new time system work with 60s and 64s and 365s and stuff like that, rather than like dividing it into tenths or something. Okay. Now, how many hours are there in a day? 24. So you divide by 24 there, because you're trying to get today. You're trying to turn the number of hours you have into days. So you divide by 24 there. Then you take the days and divide by years. Although technically, I guess you might argue that it's 365 and a quarter. You're going to learn this later, but time, the nature of time and keeping track of time is horrendous, and it's not your job to do it. It's somebody else's. Because when they started throwing in things like leap seconds, I just threw up my hands and kind of walked away. Yes, leap seconds. They're a thing. So then we can print those. Now with this one, you actually want to print the years, months, date, and time as the minutes. That can be a bit harder depending on how you interpret that. But I want to go on to the next one. Here's a question a friend of mine likes to use, an interview question. How many trees are in the state of Washington? Right? We could just Google that, but that just gets us like to the next question of how did you calculate that? This may seem like an impossible question to answer because you can't really go out and count all the trees, right? But getting an exact answer is not the point of this problem solving technique. Just getting a ballpark is just kind of the general idea. To actually compute the answer, that would require you to make some assumptions or guesses or estimations about how you come up with an answer. So let's brainstorm for a second. How many trees are there in the state of Washington? So first off, we're talking about the state of Washington. Now, for those of you who don't know, the state of Washington is different than Washington, D.C. And I say that like, I know a lot of you US are like, who wouldn't know that? Well, we have there's a number of students here who don't necessarily know, because they're not from this country, So Washington is right here. It is this state. We could say it would be the most northwestern state, except that Alaska is technically the most northwestern state. And here, Alaska gets short shrift again, making it appear way smaller than it actually is, Now, for those of you who don't know about the way the population map of the US works, there's lots of people here and here and here and here, but not so much in the middle. The middle's and the further you get out west, the less this kind of area, gets a bit less dense in terms of population, right? Right. Population density of the US. Let's go and look for a map. Right. You probably see some things with this with election results and stuff like that. People like to remove that, move stuff around with the with that. But here we can see, okay, red areas are the darker red it is, the more populous it is. And you can see that this northeast megalopolis is pretty big. That whole Boswash corridor, Boston to Washington, D.C. I mean, it's not really fair to call all of that, but I mean, like, there's some, but you can see there's some places more than others that are more densely populated, but there's a lot of space that is in the West that is unoccupied. But Washington is very well known for, well, having such a huge amount of trees. So there's a lot of nature in Washington. So the question is, so a good way to go about this is, let's figure it would be, okay, how big is Washington? First off, that's pretty easily to look up on Wikipedia. The next thing to look up is how much of the state is forest? That's part 2. And then part 3 would be, what's the average? What is the average amount of, what is the average number of trees per square mile? Right. So somebody posted, hey, there's 66,582 square miles of Washington that are land areas. Why is that important? Well, we can break it down right over here. Land versus water, right? So we can use 66,544 or the number that Isaac posted. Really what matters is the 66,000, right? It's that it's the order of magnitude is correct, right? So so now estimate how much of that is forest, and then estimate how much forest is there in how many trees are in a square mile of forest. All right. And then so how are you supposed to do that and calculate that? Well, throw it into this program. Well, make a small program that kind of converts it in the same way. So let's go ahead, and I'm going to again, do you want me to break you into breakout rooms, or do you want me to just keep us here to work on this one?
I'd rather keep us here.
All right.
Yeah.
So let's take.
Yeah, just keep us here.
All right. So let's take 5 minutes, and why don't you all argue, and you can argue out loud or in chat about it. And I'm just going to simply stand by. Or you can work on your own. It's perfectly fine. But in 5 minutes, I will start asking people for volunteers. I'm not going to make anybody do anything to give us to come up with it if you want to share your answers. don't worry if you have no idea what you're doing. So let's go ahead. I'm waiting for people to try to brainstorm, and I'm going to go ahead and then I will work on it from the perspective of everybody else. What you're trying to do is figure out how many trees are in the state of Washington. Right? So how do we go about figuring out the state of Washington? A beer posts a link. Let's go ahead and see it. And I've been rickrolled yet again. No, I'm just kidding. But let's see. It says the estimated biomass is 147 tons per acre. So about 22 million acres of forest cover that land. So let's go with that. 22 million acres of forest. So then the question is, how many trees? So how many trees are in an acre?
Around 40 to 60 if it's a healthy forest.
An acre of, how many trees in an acre of forest? Right, and I'm doing the same thing as you. We're not just pulling these out thin air, although you can. How many trees in acre of forest? Right, so it says a healthy forest has 40 to 60 trees per an acre, according to sbcounty.gov. So, an average acre of northern hardwood forest contains nearly 5,500 trees. So 60. So we can get vastly different estimates, because this is saying 100 to 200 trees. But this one is also, if you notice, from this PDF that it's scanning over here, it says that it is containing seedlings or saplings. 128 are larger trees and 8 are dead standing trees. So this is an estimation from the Forest Service for New England, which is different than Washington. But heck, I'll go with that. And they're saying that, okay, we can discount 5,300 of those. And so when we say 100 to 200 per an acre, where it's overstocked, and then we say that 182 are larger live trees. On page 51 of that, it says there are 25 trees per an acre for Washington. But is that 25 trees per an acre or 25 trees for a forest, per acre of forest, or is that for the entire landmass on average? Go ahead. Control F25. Or I can just search per acre. Let's see. See what comes up. Carbon mass per acre. It's always dangerous to kind of do this. Don't even know what a snag per an acre is, right? But I think I'll go with the easier estimate I have of using around, it says 40 to 60, because then I can use 50 as my estimate of trees per an acre. So let's go ahead and show you kind of how this do. Let's go ahead and do input. How many acres of forest? Okay. And we got that there are, and I'm going to grab again from this website over here that says 22 million acres of forest. Okay. That's what will be my input. Let's go ahead and say that again, acres is equal to input is equal to int. Got to turn that into an integer to work with it. Okay. And now let's go ahead and say, and then we just use trees per an acre, which is how many trees per an acre?
Professor, I have a question.
Uh-huh.
Couldn't you do int input?
I could. But for right now, I like to break it, but especially in the first couple lessons, I like to break it up into multiple lines to not make it totally intimidating.
Okay.
Right. I could totally make this a one-liner, but that would look really scary. And readability is one of those big things that I like to emphasize. So let's go ahead and look. So you ask how many acres are in the forest, get the number of acres. We're going to estimate there's 50 trees per an acre, right? Based off of the fact that our cursory Google search said we got a healthy forest saying 40 to 60. We saw that this New England forest from the Forest Service says there are 55,000 trees per an acre, but 5,300 of those are seedlings or saplings. And it says that they are also the highest density of all major forest type groups. So that makes sense that they would be maybe twice as dense as a average one. And that 200 is an overstocked forest acre. So it makes sense. Those numbers kind of match up. So I'm okay with going 50 with 50. So I can say trees is equal to 50 times the number of acres. And so I can print there could be, because I like to hedge my language, and then I can put a comma to put in a variable over here. Trees in that area. So 22 million. So that's 2 and then 6 zeros. 1, 2, 3, 4, 5, 6. And so that gives us about 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion trees. Stephen said he got 1, 2, 3, 4, 5, 6, 100 million trees. So we can get quite disparate answers from here, depending on that. So somebody says he got 1.35, right? Answer is a lot. Now, of course, we kind of limited it to forest, right? Not all this land is forest. God knows that everybody likes having a tree in their yard, right? So, we could up that amount, but what was the acres again? The acres were about 22 million acres. More than half of Washington is forested. About 22 million acres of forest cover the land of 42 million acres. So and again, this is coming from the Forest Service, which seems like a perfectly reasonable source, right? So we can take these kind of questions and just do a very quick bit of Googling. I was mainly monitoring the chat until I started working on this. Then people said they had no idea. So I started working on it so I could kind of show them the thought process. But this thought process, it did not come naturally to you. That's okay. Because this is like kind of this crazy estimation skill is kind of one of those weird things that you just kind of pick up the more you work in the sciences or the more you answer these kinds of questions. One of my favorite kinds of these questions actually is the Fermi paradox, which is, let's go ahead and just take a look at the Fermi paradox. Where are the aliens? It's named after Italian-American physicist Enrico Fermi. And it says, hey, there's basically, let's see, what is the equation? So it's based off of this principle called the Drake equation, which is the probabilistic argument for there being aliens, where n is the number of civilizations in our galaxy with which communication might be possible. Let the variables be the star formation, number of planets, how many of those planets make life, yada, yada, yada. Fermi's paradox was, okay, you've got this convention equation that says we should have alien civilizations that we should be able to communicate with. So why is it so darn quiet? Yeah, Xkcd had a great video on this. But again, this is just kind of napkin, even though it's got scary looking letters here. complicated looking letters. He's just doing the same thing we were just doing here, which is just literally like doing some basic research and saying, okay, let's just mash these numbers together or multiply them together until we get a probability. So that's one kind of fun thing you can do with these. There's various answers as to why it could be so quiet. We're special. That makes me feel special. And by the way, whether or not we are the only intelligent beings in the universe, either answer is very interesting. So why is it so quiet? And my favorite short story is like we send out signals into space, and the reply we eventually get back is "Be quiet, they'll hear you." So there's all sorts of just interest. It's a skill that mathematicians like to develop. It physicists and scientists like to develop. It's a very useful skill to have to be able to just do a baseline estimation. So let's go on to the last part of this one. How many handshakes? Bit more physical, right? But unfortunately, we can't do handshakes anymore because COVID. Oh, you want to copy and paste the code for the tree? Watch this. No need to copy paste. Watch this. 3, 2, 1. Share. I'm going to hit share code. Rachel, I'll be happy to take a look at your code in just a second. I'm going to share this code with you. Once you refresh your page, you'll be able to load up this code. Okay. Can you optimize your MacBook? I don't know how old your MacBook is. I'll be happy to discuss that at the end of class with you. So what I'm going to do is I'm going to go ahead and introduce this problem. Then I'm going to address somebody who's, yes. So somebody the person who just messaged me saying they want to look at your code, copy your code into the chat, direct message it to me. Okay, I'll be happy to take a look at that after I look at this. So, all right, how many handshakes would it take for everybody in our class to shake hands with everybody else? You should not shake hands with any person twice, and you don't shake your own hands. So, let's see.
Is this going to be for only in our classroom or the whole city?
Well, we could start out small. The idea is to generalize it. So what if the class had only 2 people in it? How many handshakes would there be? Right? If it was just Alice and Bob, the classic people in computer science, right? A and B, we'd have 1 handshake. Okay, let's say it was Alice, Bob, and Carol. Okay. So, right, 2. You'd get Alice and Bob would shake hands. Well, Alice and Bob would shake hands. Bob and Carol would shake hands. 2. Oh, and A and C would have to. So A, B, B, C, A, C. You say it wouldn't be 6 because, right, A and B shaking hands is the same as B and A shaking hands, right? If Alice and Bob shake hands is the same as Bob and Alice shaking hands, right? Make sense? Although somebody points out, hey, is this factorial? It seems like it, but it's not quite, right? Because right, what is factorial again? For those of us who have had way too little math and just want to completely check out during the the winter break, right? Factorial is basically this weird product thing where we say, hey, it's a shout. This shouty 3 is equal to actually 3 times 2 times 1, right? So 3 times 2 times 1, which would be equal to 6 in this case. Let's go ahead and look at 4 factorial. And so 4 factorial would be 4 times 3 times 2 times 1, right? Shouty 4 is equal to 6 times 4, which is 24. So let's take a look now about 4 handshakes. Let's think about that, 4 handshakes. Okay, we've got Alice, Bob, Carl, and Dan, right? Carol and Dan. So A needs to shake hands with Bob. A needs to shake hands with Carol. Alice needs to shake hands with Dan. Okay, now let's look at Bob. Bob's already shaking hands with Alice, so we just need to do B and C need to shake hands. and B and D need to shake hands, and C and D need to shake hands, right? Those are all the combinations here. 6 people. So 6 handshakes, right? That makes sense? Alice and Bob, Alice and Carol, Alice and Dan, Bob and Carol, Bob and Dan, and then Carol and Dan. Did I miss anything, by the way? Because I do not claim to be the be it all, end it all, know it all. I am definitely not that guy. 4 choose 2. So that's a statistical thing, but not everybody's taking their combinatorics and permutations. So let's go ahead. So go ahead and start working through this and try to find a pattern. Write down results for the small numbers and see if you can figure it out. Once you figure out what that pattern is, try asking the user for the number of people and then compute the number of handshakes and print that number. And let's go ahead and say that the number of people in our class are the number of people in this Zoom room right now. Got some very good suggestions in the class, but we will take actual answers in a bit. So once you get it, I'll start taking answers from people. There are 141 people in this Zoom room right now. Okay, so let's go ahead and take 5 minutes to try to look at this, and then we'll look at some other people, and then people can share their code.
Professor Rosen, I still have a question. So when you shared your code for the trees, I don't know how to see the code that you shared with everybody. Like I see like save and run and show code and lens. Oh, you're muted, by the way.
I got the notification saying I was muted, so I had to find the button that said unmute.
Yeah, no problem.
I type loudly, so I tend to mute when I'm typing.
Yeah, no problem.
So you should be able to refresh your page, and there should be a load history button. So if you refresh it, which I'm going to do right over here, there will be a load history. There you go. Make sense?
Yeah, but it's giving me a syntax error. It says bad input on line 4, and I have quite literally the same. Oh yeah, no, never mind. I just loaded my old code. Never mind. That's weird.
It's okay. Let's go ahead and I'm going to go ahead and start working on this myself by just figuring out the patterns.
Professor Rosen, there's a pretty simple formula you can use to figure out your numbers if that's what you want.
There is a very simple formula, but you might not know it. I'm very familiar with the formula for triangular numbers, though.
Gotcha.
Um.
Can I ask a quick question? I've seen somewhere that it's possible to generate like numbers, like random numbers, but in a sequential sequence, I guess.
Like the numbers 1 through 5 or something like that.
Yeah.
Yeah, you can use a for loop. We'll be learning around for loops later. Yeah, there are currently 140 people in this. There were 141 when we were when I started the problem. So yeah. Yeah. Yep, I hit 3 instead of 2. So okay, let's go ahead and look at my notes over here for those of you who are stuck. So I was doing, so first thing I did is I kind of did the number. So I figured, okay, Alice and Bob, they shake hands, one person. Carol, you add Carol into the equation, right? 2 people shake hand. You've got the original handshake, and then both Alice and Bob need to shake the new person, which is 2. So for 4 people, you have all the original handshakes, which was 3, right? And then you got to shake your hands with all the with everybody's there has to shake hands with the new person. So so we had 3 people previously. So 3. So we added another 3. So 5 people. Well, we had 6 previously, and we had to, and so now 5 of them had to choose. Notice what's going on. We are increasing. This increases by 2, then 3, and then 4. And then notice I said, okay, I'm going to guess 15. And then I wrote it out, and we had 15. So the pattern seems to be that, hey, we are adding, we basically got this nice equation here. Or not this equation, but this kind of sequence here. So what did people do next after they figured out that sequence? Anyone?
I think I did this wrong, but I did people times 2 minus 1.
People times 2 minus 1. It's close actually to the equation you want, which is for triangular numbers. Not that now I know this because I happen to be a bit of a, I think that, in scientific terms, I believe it is called a nerd. So, but I happen to know this because actually these come up really commonly in computer science. A triangular number, right? By the way, probably not going to get many other professors to say this. Love Wikipedia. Wikipedia is the greatest thing. So triangular numbers simply say, hey, we're building a pyramid essentially. And each number in the sequence basically is adding another layer. So this looks a lot like our sequence: 1, 3, 6, 10, 15, 21, right? The difference here is 2, 3, 4, then 5, and then 6. Right. So the triangular number, and it does have this nifty equation, right? I know somebody was saying n choose 2, right? Which makes sense because of where we were starting with. Now you said, did you say, Stephen? You had n plus 1 divided by 2?
No, I said people times 2 minus 1.
People times 2 minus 1. So you got a 2 in there, right? But you'll find this equation a lot in computer science. N times n plus 1 over 2, which is our equation. Now, how are you supposed to figure that out from this? I'm not really sure, but but the triangular number solves the handshake problem. If each person in a room with n plus 1 person shakes the hands of at least one person. So it is essentially now some of you who were saying, saying that this was a factorial problem, you were actually really close because this is the addition version of factorial, essentially. It's not multiplication, the addition version of factorial. So it makes sense that that your initial idea is to look at factorial, right? Right, this is the numbers 1 plus 2 plus 3 plus 4 plus 5 all the way to n. So let's go ahead and let me see. So how many people are in the room? N choose 2? Yeah, totally. Because notice these are equivalent. Now notice that this has an n plus 1 over 2. That's perfectly fine. N plus 1 versus n. You'll see, I mean, it just depends on what we do. So let's go ahead and see. It really just depends on how we modify our equation. So let's go ahead and say input. How many people are in the room? Question mark. N, and then we turn it into n is equal to an integer. Then n is equal to, and then we say handshakes equal to, let's see, n times n times n plus 1 over 2. And yeah, that'll give us a decimal number, but that's fine. Print handshakes. Not going to be fancy or anything about this. Print it, handshakes, run it. How many people are in the room? Let's go with 6 and see if our number matches. And we got 21. So this is what we call in classic computer science an off by 1 error. But that's fine because guess what? Now, how did I get what how would you possibly get from this sequence over here, 1, 3 to triangular numbers and their equation? Well, we know what those numbers are. And so believe it or not, Google's pretty good at figuring out what numerical sequences are. Oh, look at that 1, 6, 10 pattern. And it will say, and it will bring you to math.com, isfun.com. What is the formula of this sequence? Is there any way to form the sequence? Now notice that basically that I put in 6, so I'm getting the answer for 7. So essentially it's just, I'm 1 off because of that. So maybe what I can do is I can just subtract 1 over here to make it work. That's too many. Put in 15. I wanted 6. I wanted 6 as my answer, and it gives me 15 people. Right? Because it is for, again, if you've got, because again, now why was that not working? Because the equation that we were given is for, let's see, the triangular number of essentially n plus 1. It's given for n plus 1. So if each person in a room with n plus 1 people shakes hands with n plus 1 other people, sorry, if n plus 1 people shake hands with each other person. So we wanted to do 1 less than n plus 1, which would be n. So hence why I was subtracting 1 there. Another way to subtract 1 is to literally subtract 1 from this equation. From that, and then remove this plus 1 because plus 1 minus 1 is that. 15, 5. And so, hold on a second. 6. So that matches. And so now we have 140 people, which gives us an answer of 9,700 handshakes would need to occur. 9,730. So I will share this code with you. So I know this difficulty accelerated quite quickly here. If you were struggling with it, this is perfectly fine. I do like to basically go go and like kind of blast your brain in the first bits of the in the first couple weeks, because otherwise I'd just be droning on about really boring stuff. I prefer to kind of show you the kind of exciting things you can do with basic calculations.
Professor, what was
Mhm.
the problem there then? Was it just like the parentheses around the
No.
like the n1 and n?
Oh, why
like,
did I have to subtract one? I had to subtract.
Yeah.
I had to subtract one because I was getting a bit more than I was bargaining for. Right when I was putting in n, it was giving me the. So say if I was putting in 6, I need 15. But what I had was this, which is the what I was said to put, which is what told me to put in. So I was put in 6. I'm expecting 15. I get 21. I'm looking at my table over here. If I put in 7, I'd get 21. So let's confirm. If I put in 5, do I get 15? Yes. So essentially it's off by 1. This answer will give me this answer. This will give me this. 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 Right? So it's essentially what I need to do is kind of just subtract out 1 to get it to work, right? Because my input to this equation, if I subtract 1 from it, then the output becomes this. Does that make any sense, or did I lose you?
Yeah, I'm good.
You sure?
Yeah, I was just a little confused with how it was coming up at first.
Right.
But
The other thing
I'm
I
good
can do is I can say, okay, I want the answer before, and I can subtract 1 from n in this equation, which is the same thing I could do over here. And that's, so subtracting 1 from n, 10 is going to be 45, 7 should give me 21. Now what happened there with nothing coming up, I hit enter. And so it said, hey, you can't turn a nothing into a number. Yep, if Moonstone marks it as complete, it's fine. If you leave the page, yes, you're going to lose out on, the code's going to go away. But let me show you what happens when you leave the page, right? Your code's going to be blank, but if you click this button over here, load history, oh, there's my code, right? Makes sense? So let's see your answer. So 140. And so 141 would be 9. So Taylor, that, yep, that's why, because you're dealing with the off by 1 error I'm dealing with. All right. Other questions about this one? Again, I'm going to share this code with you so that you can use it. Now, be sure to complete these post-project questions at the bottom. They let me know just let me know how stressed out you were, essentially. And they let me know kind of anonymously. So as you can see, don't feel bad if you feel like it was tough, right? All right, so I'm going to go ahead and stop sharing for right now. Okay. So overall, again, so let's go ahead and talk about, the quiz, right? Quiz time. We have a quiz. Not today, but quizzes in general. Okay. So let's go ahead and I'm going to share my screen. You can find your quiz, right? It'll be linked over here, but all your quizzes are under assignments as well. Notice it says the late penalty will take effect after 45 minutes. Okay. So the way you do work on a quiz is you click on it. Okay. It's worth a certain number of points. Now the points are not like, quiz points are not the same as assignment points. Okay. You got to understand that quizzes are their own category. Okay. So some quizzes later in the semester may be worth more than other quizzes, right? It just depends on question by question basis. So now this first off, this quiz is due the 6th. Today is the 8th. So it's due next week. Plenty of time to do it. You can take it anytime you want before it. Now, first off, if you have, I'll tell you about the pause in a second. Okay. Do not, and I highly recommend you do not start the quiz unless you're ready to take it. So first off, if you have I got to pull this up on our channel. That's just simply my music making channel. So here we go. So let's go over here. If you are having issues with the quiz, don't post it here. Post it here in quiz issues. That if you're having issues with the quiz, email me, or quicker response will be right over here in the quiz issues. Okay. In general, if there's issues like where I need to, if I get a bunch of students saying, hey, I need you to manually grade something because your auto grader was terrible, I'm going to go ahead and then I'll make a Google form where you just simply put down your name and it gives me a list of everybody who needs me to grade their questions and stuff. Okay. So but quizzes are pretty good. Or rather they'll help out quite a bit. Let me go ahead and sorry, the quiz issues sheet, words hard. The quiz issues channel is a great way to get into contact me if you have a quiz. So once you start the quiz, right, essentially you're on it. So I'm going to just go and show you an example. I'll start it. Here's like the first question you'll get on the quiz. So, refer back to this or hit your print screen right now to capture what the first question is, right? But you'll be able to run your code, and notice that there is a pause button, which does that. Pauses the timer. Okay. It removes the question, allows you to step away and get you get a drink of water, go to the bathroom, whatever, right? It pauses the quiz for you. Hit resume, the time starts resuming. There is no time limit per se. There is a late penalty that I will try to put into effect 45 minutes, but I don't think it's going to take 45 minutes, right? Now, a couple things. Note the big warning. You'll lose all your work if you close the tab or the browser. Closing the tab or the browser will lock you out of the quiz, and it'll make you come to me asking me to reopen it for you, which is okay when it happens the first time, but it kind of gets annoying and a bit grating on my nerves after I have to do it for 20 students. So, so don't close the window, right, once you start. Don't close the tab once you start. The other thing is that because of the way modern web browsers work with caching and the like, you'll want to, if you're, so say you're working on the quiz, right? And you do this. Okay, question, I needed to convert a string to an integer. How to convert string to int in Python, right? You'll do that, and if you hit enter, you'll navigate away from the page, right? String. You'll navigate away from the page, which will close the exam, right? Instead, what you want to do is keep this open and go. And if you want to look something up, which you can because it's an open book, open note, open web quiz, do it in a separate window. And I suggest a separate window because of the way that some modern web browsers work. The way some modern web browsers work is that if you've got a page and if you've got a tab in the background for a while, it will unload the tab and reload it once you come back in. Okay. So it's not going to happen like when I've got a couple tabs, but if you've got like 50 tabs open and you jump around to another. So that's why I suggest have a separate, if you want to work on something like that, work on a separate window. If you have an issue, let me know in quiz issues and I'll reopen it for you. But this is just to try to prevent any kind of craziness about the quiz that might happen. Any questions? Yes.
Yeah. Do you recommend like pausing it often? Like, do you think that's necessary to keep it under 45 minutes or?
It's not going to prevent you from submitting it after 45 minutes. There's no time limit for you. There's going to be at no point when it rejects your answers. Okay. There shouldn't be a need to pause it because of course you could abuse the pause feature. They have no way of preventing that really. I could see what you're doing on the exam in the logs, right? I can go through the logs and seeing pause, unpause, pause, unpause. So, just be honest about this. This is, I don't expect it to take very long because if you notice, it's 4 questions. So, so again, it's a lot. This is unproctored. It's on your honor. And by doing it, doing it honestly gives you the best results for yourself. And I'm going to try to give not necessarily a quiz every week, but at least every other week, so that you guys have plenty of chances to make up stuff, so that failing a quiz won't mean that you bomb your grade or anything. Make sense? Any other questions about the quizzes? What is the point of the time if it's not timed? So I have a late penalty policy. Okay. The late penalty policy is, well, first off, I need to see if I can keep track of the number of minutes that it takes. Regardless, basically don't take the quiz. And so basically take the quiz and don't close out of the browser or tab until it's submitted. Yes, that is essentially it. What's the point of the time? So my late policy, let me go back to that. Late policy is as follows. For every minute late, it's 0.1% a point off. So if you submitted an hour late, it is 6 points off. If you submitted 10 minutes late, it's 1 point off. Or sorry, 1%, 6% of the total points, right? 1% or 6%, or if you submitted 2 hours late, it would be 12% of the total points, and so on and so forth. So I don't know if there's a way for me to really keep track of your time here. So there might be, there might not be. If there is, then the late penalty will apply to this. If there's not, then the late penalty will definitely, no matter what, apply towards getting this. Right. So, yeah, especially, yeah. So the deadline for taking the quiz is pretty hard. If, of course, you like catch COVID or something, or, you break your ankle or get into a car accident, or, have to suddenly deliver a baby or something like that. All things that have happened over the past semesters, right? Obviously, you can have an extension, right? I'm going to be reasonable about it. Okay. Anything else? I will stay behind class so that if you have some code you need to show me, I'll be happy more to take a look at it. Any other? Oh yeah, it's 3:22. Class is dismissed totally. If you've got any additional questions,